Well, hello, everybody. So yeah, as Tanya just said, we're talking about quality of probability-based panel samples, so a quality session. And we have a wonderful set of speakers lined up, and we'll hold the questions till the very end. So we'll go through each individual talk and then ask questions to each and all at the very end. So we're starting off with John Krosnick. John Krosnick is Frederick O. Glover Professor in Communication, Political Science, and Psychology at Stanford University. He's also director of Stanford's Political Psychology Research Group and also research psychologist at the US Census Bureau. So you know this is a busy man. He has expertise in questionnaire design and survey research methodology, voting behavior and elections and American public opinion. Go ahead.
Matt, I don't know that we have John yet.
Oh,
so we might have to
go with
Michael, who we know is here.
Okay, so I'm sorry about that. So yes, so let me talk about Michael then. Michael, Michael Ochsner received his PhD in sociology at the University of Zurich, Switzerland. And I know he's there because we chatted before we started talking. He worked at the ETH Zurich in the field of research evaluation, and he is now, since 2013, he has been working at Force, and where he's involved in the implementation of the European Social Survey, the International Social Survey Program, and the European Value Study. So, and Michael will talk to us today about Are Probabilistic Online Panels Representative? A new framework for the analysis of representation bias. Go ahead, Michael.
Thank you very much for the introduction. Shall I share my video or just the slides?
Then turn your camera on, please.
All right. Okay, thank you very much for the introduction and for the ability to present my research here. It might be a little bit an outsider position, as you could hear from the introduction. I'm more in the context of cross-sectional surveys that might not have a really panelistic approach. And in this context, I was responsible for analyzing representativeness of samples, of surveys, online surveys, and I developed a framework to do that. And I wonder whether this could be expanded to panel research. And that was the question I had to myself when applying to here. And this is where I'm trying to get in and propose what I have thought about cross-sectional analysis and suggest how this could be useful to assess also online panels, issues of representativeness. So the motivation is that probability-based online panels are increasing in importance, and often they are recruited after an initial probability-based survey. So after the ESS, people are invited to take part in Chronos, which is then a panel survey that takes on the same study as the ESS has been on the web. So changing from face-to-face to on the web. Similarly, many COVID surveys have been conducted across Europe. As I know, there are other surveys as well that work like that. We have ourselves implemented such a survey, such a COVID survey after the International Social Survey Program, which starts with web paper, and then it was transferred in a web panel on COVID topics. And then, of course, the question arises whether even probability-based online panels, what is the risk of representation bias, and who can answer on the web? And we have the additional problem of attrition, of course. Now, the question is then, what is the risk of representation bias for probability-based online panels? And this is a too big a question for 10 minutes, so I break it down to how to identify the risk of representation bias. So representation analysis is part of our work if we do survey research. And often statements about representation of surveys are made. Yet the concept, as you know, is contested since a long time, and it's kind of difficult to talk about it from a statistical point of view. So I'm trying to examine the use and misuse of the concept and how to cope with those problems. That's the motivation of the study. The concept of representativeness is contested in statistics since a long time. It has no clear meaning, and it might be practically problematic. Yet it is something that seems to be useful and needed in the communication of the usefulness of surveys. There is a seminal work by Kruskal and Mosteller that you might all know from 1979. They had 3 articles where they investigated the use of the term, and I think it's still very valid. It's still the same issue, still the same discussion. So I think it's very useful to start from here. They identified 6 types of the use and defined it a little bit more clearly to 9 types, but we stay with the 6 types. They found that one very often used use of representativeness is general claim for data. So, for example, we use R indicators. We see that they are quite okay, and we say, okay, our data is representative. So we pat on our own shoulder and say, our data is good. You can infer to the population. The second thing is also related to R indicators, for example, is absence of selective forces. So they say, okay, we cannot find a response bias. So from our data in our initial samples on sex, age, marital status, etc., we don't find that the response across those variables we have in our sample data, we don't find it related to response. So we have an absence of selective forces. So we don't have a representation bias. This is a problem because we know that the link between those sociodemographic variables and the variables of interest are usually low. And that means that an absence of selective forces does not mean that there is bias of our question. And a presence of such a bias is also not a proof that our other questions cannot be answered. Very often used is also miniature of the population. That goes with, for example, population statistics. I see that regarding sex, age, region, etc., I have similar distribution from my results as the population, so I'm confident. This is problematic because we can run into an infinite regress, right? When are we close enough, and how many variables do we need? So this is again a problematic issue. Then we have a typical ideal cases that's less of relevance for survey research. This is often used for typologies or so, that you kind of represent some countries. For example, you have Russia representing Eastern Europe, you have Australia representing Oceania, etc., etc. Then coverage of the population is something very similar to miniature of the population. You decide that having, for example, race and sex covered correctly, it doesn't necessarily mean in the right share, but at least you have, of all categories, you have people in the population. And finally, there is the representation as a vague term to later be made precise. That means you use representation as a simplification of saying we have a probabilistic sampling frame, we have inferential statistics, and this means more or less that we have confidence in our representation of our study. And they finally conclude that the first 5 types should not be used for representation. It's not representative because it's not precise. They rather suggest to use the 6th type to use representation as a term for having a probabilistic sample and having inferential statistics, that you have some statistical meaning in how you make confidence in how you make inferences. Now, the practices of representation analysis usually in survey research is using the sampling frame, right? If you have a probabilities-based thing, then you have a sampling frame and you look at non-response bias. So this is using type absence of selective forces. You can also use population data. Here you have the use of miniature of population. Very often both are combined with shoulder patting. You make a general claim on the data. And this is problematic because it's not scientific. So the question is, what can we do? We have to acknowledge that representation is context dependent, and the context is given by the purpose you use. So the starting point should always be the analysis for what is the data used. So we try to avoid two things: claim for data, so that we have a general conclusion for a whole data set that is representative, but we say that for one use it is okay. It is there is no concern, not a high risk of bias. And finally, I think we can do that if you have two dimensions covered, and that's why I have this developed this kind of framework. On the one hand, we have types of variables we can use. We have participation, so the sampling frame data. We have control variables, population data, usually socio-demographic variables, and we have variables of interest. That is actually what we want to know. And then we can do different things with our data. We can look at distribution, we can look at correlation, multivariate analysis, and these come with different assumptions on what kind of bias is okay. Because in multivariate analysis, I can control for certain biases, while if I use only a subpopulation, if I have a bias there, I cannot control for that bias. So that the indicators we can use differ across what are we doing with our data and what variables are we looking at. And we can play that through in general. And I use data from Mosaic, which is a general population survey. It's fielded in two parts, on web and paper. And then in 2020, it was added a COVID panel. And what I find, if I apply all those indicators, and unfortunately, I don't have population data to date. I received sampling frame only 2 days before. But what we can find is that if you use the different indicators, we find that the result is changing. And we find, for example, that sampling frame data show that there is very small bias overall, so there is no concern. But if you look at variables of interest, for example, trust in institutions and political interest, we see that there is a massive increase of like 10 percentage points and also clear differences in multivariate analysis. So to conclude, there is a high risk of bias due to attrition, as we found increasing problems throughout different waves of our survey. And no response bias regarding sampling frame does not mean no bias of variables of interest. However, in a panel, we have the advantage that we have more variables of interest available because we have several waves. And of course, we can also use different methods to assess bias regarding our variables of interest. So that was it from me. Thank you very much for your attention, and I'm looking forward to discussions.
Yes, thank you very much. Great, thank you. So we'll hold the questions till the end of the session.